Let's start. Good morning, everybody. We'll talk about security and fraud. And the first thing is, let me tell some stories about fraud, some stories that we have lived on the last years. Okay, this is me, Flavio. I'm CTO of SIPPulse. We develop soft switches in Brazil, so we work for several VoIP providers, more than 40 customers on a base. I'm a founding member of the OpenSIPs Foundation, so we do a lot of soft switching proxies. And so we have lots of stories of fraud because we have to deal with a lot of customers, a lot of users using SIP. I'm the author of 2 books, Building Telephony Systems with OpenSIPs and the Asterisk Configuration Guide. This is quite old. Okay. Agenda. So I'm going to talk about practical cases of fraud, some honeypot statistics, simple measures to prevent fraud, going deep in fraud detection and prevention, and using an SBC integrated with a fraud prevention system to help with fraud prevention. First case. Our first case with fraud happened in 2007, actually. It was on an IVR that was open to dialing. Some customer has this idea, hey, I want to give the possibility of my sellers to make upsales when they were selling real estate. So they were in the real estate small place, and when they start, like we call they're there just to sell and say, okay, you can call customers. And they open the IVR for the guy to receive the call and then sometimes return this call. The passwords for this IVR went public and $100,000 on fraud on the system. Actually, it was funny. The motivation was very simple. The motivation is always the same. It's money. What happened? In Brazil, we had a scheme with cell phones where you can put credit on your cell phone by receiving calls. So the company has the interconnection rates, it has the right to interconnection rates, and the mobile company was sharing these interconnection rates with the users. So the user could receive credit by receiving calls on his phone. And then some guys discovered how to sell credits using somebody else's telephony. It was one of these cases. They used this IVR to put credit on several of these cell phones, always from the same company. So in most cases, the fraud are caused by arbitrage. So we started to be very concerned because this case went to the court. It was a real mess. Massive attempts in 2010 and 2011. In 2010 and 2011, the things started to get very serious. We have SIP issues causing flood. This guy created a software, an amazing software for hackers. It's very easy to spot servers and to find servers. And we had some interesting phenomena too in 2011. It was the Sality botnet. Sality is a botnet, and this botnet has several payloads. And one of the payloads in 2011 was SIP issues, was a variation of SIP issues running on the botnet. So we had something like 200,000 machines running SIP issues at the same time. On the mailing list, everybody was saying, hey, there are several machines on the EC2 attacking my servers. Everything is down. There's a lot of SIP flooding. So we started to get very concerned about security. So we started with the first measures, firewall and fail to ban. So in 2011, it began to be mandatory to run fail to ban. Without fail to ban, you couldn't survive on the network for a few days. Why? The problem with SIP issues, one of the first versions actually generated a flood. Generates lots and lots of requests. The newest versions do not generate the flood, so the problem is now a little better. But the idea of DR, hey, block this on the Cisco in front of the system, it's very clever because you can actually protect your server from the SIP flood. So I started to get very concerned, and I said to all my technicians, hey, pay attention. These guys are trying everything. And as all employees, they said, it's okay. Everything is protected. There's a firewall in front of my servers. I have protected my servers. Don't worry. Everything is fine. Okay? Oops. Everything is fine, as I said. And then we got the second cause of fraud. And it was caused by SIP issues. We had a customer with weak passwords, very weak passwords, 1, 2, 3, same name of the. And I said to the guys, these passwords are weak. He said, don't worry, it's behind a firewall. It's a call center. No one access from the outside. And one day we have a flooding on the city, right? And no one could work at this day, right? So the manager had this idea. Let me put all the agents at home. They can get the calls at home. And they call the tech support and say, please open my firewall to the external world. And the guy on the tech support say, okay, let's do it. You're asking, I'll do it right now. I'm very efficient. And 1 week after we have an event, and the user was defrauded $3,000. Not bad. 3,000 was really not that bad, right? We had to split this bill. We considered that the fault was for both of us. How the fraudster works, how they are working. They usually assign a premium rate number on the internet. You can go on the internet right now and assign or buy a premium. Actually, you are not buying because it's for free. They give you the premium rate number, please generate traffic, and they share the traffic for you. You can go on the internet. There are some ones, I went to one of these websites, put my name there. Actually, they have a control panel, sometimes better than the SIP providers. You can see exactly the amount of money, the number of calls, exactly what you're receiving on the other side. They are really very, very clever on this. Then find the target, generate traffic, and cash in the credit card. And this becomes a fever on the internet because it's the simplest way to make criminal money in the world right now, right? And the attacks started to grow. In Brazil, we have a product called honeytart.cert.br. It's not our product, it's a product from Oregon, Brazil. And they have honeypots. This is the trend in the port 5060 on the last years, right? So we had almost more than 6 million hits on a port 5060 on February of this year. And I would say that in the last month, it was a record. It went to almost 7 million hits on the honeypots. So it's increasing. They are trying every single day to find an open PBX on the internet. Why? Because it's easy money. You can go there, go buy a premium rate number, generate traffic, and cash on the PayPal. And as you're caching in some weird places in the world, the chance of being catched, it's very, very low. Right? So it's the perfect crime. And we are the victims. Yeah? Every day we're fighting against this. It's funny to see, I put this graphic here to show you something. You know the second one, the port 53, the DNS on the UDP, 25,000 hits. If you go to the TCP, they are even lower than this. Look, 2.5 million hits on the port 5060 and 20,000 hits on the port 53. So if you sum all of the other attacks on the internet, you cannot beat the attack to the SIP port. We are the target number 1 right now, by far. It's not by far by 2 times, it's by 100 times, right? Phases of attack. They usually do 2 phases. Discovery, they send an options packet to say, hey, where are the machines? The second one is brute force on passwords. They send a register. And trying to register with different passwords all the time. So if you have good passwords, usually they will give up after some time, right? And the actual call attack, that in my opinion is the most important, is the invite attack. And the funny thing is they use different tools and different operating systems to do this thing. The first two are usually done using SIP issues. But the third one, they use several other tools that in some cases we are not prepared to detect. So they do not send the invite with friendly scanner, that it's very easy to spot. They send the invite with something else, right? So you have three phases, and you need to have access to the SIP request to make a good detection. It's very hard to detect on the CDRs later. You need to have an upfront detection of the problem. 6 simple actions that you can do, anyone can do to avoid attacks. The first one is use strong passwords. The second one, use fail to ban to block authentication failure attempts. Third one, and the most important, disable unnecessary international routes. If you don't need a route to a specific country, don't use it. And in many cases, I simply say to the guys, disable the international route on the TDM trunk. Do your international route through a VoIP provider that costs 10 times less than the TDM trunk. It costs $7 per minute to send a call to Gambia through Telefonica, and 70 cents to send through a VoIP provider. So your exposure in a TDM trunk is 10 times greater than 10 times bigger than in a SIP trunk. Disable unused ports. You have lots of unused ports on Asterisk. Dungey, port 4550, 4520. H33, MGCP, Nortel, Unistin. In many cases, YAX too. There are many installations where we're not using. It's a vector of attacks. If you don't need it, disable it. Secure the manager port. It's another important stuff. And protect the web access of your server, web and SSH. These are simple measures that can help you a lot. But let's go further. One of the simple measures, change the SIP port also. It's effective. It is effective. He can't attack you on the other port. Yes, he can. But look at the numbers. Port 5060, 99.04%. Other ports, 0.02%. It's not safe proof? No, but it helps. And it helps a lot. Okay, now my Asterisk is protected. So what? Attacks to phones and ATA. So we did the best job in the world. Okay, our Asterisk server is now completely protected. So we don't have to worry about attacks anymore. Then they started to do attacks against IP phones. Okay, it's not showing. Let me, 1 second. Oops. Okay, this isn't a specific phone. Let me see if I can. Okay. Okay, this is a phone, and as many phones, you still have the standard password, admin admin or admin nothing. And there are many of these phones open to the internet. So when the PBXs start to get protected, they started to attack other targets, like the IP phones. So they start trying to find phones that were open on the internet. And this one was an interesting one. They went to the phone, get there, so we need the password. So they can go and right-click the phone and check the password on the web page. Right? This is an old vulnerability. There was another phone that actually you don't need even a password to get in. There are some phones with old firmwares that you don't even need a password to get into the phone. So the password is right there, right? It's okay. Just a moment. Let me return. When the password is exactly there, right? So it's very easy. And actually, I found another way to get the password. Save the configuration in the file. You can also get the password from the phone. Good. Let's go ahead. This phone was even worse at that time. Now the firmware is much better. I really like this phone. They're not a piece of crap, but at that time, they were terrible. In this phone, you can go there, and you can go to a specific page, and on a specific page, you can dial. So you can actually craft an URL to dial from the phone. There, call a number. Put the number there, dial your premium rate number, and that's it. Right? So what's the consequence of this? Okay. The concept was $9,000 in prepaid fees to a specific customer, just done on a single phone. I have another customer that has a single port ATA, FXS, FXO, an SPA 3102, right? The guy found access to the FXO in 1 month, caused a fraud of $20,000 in a single ATA connected to a PSTN line. One line. Open, plug it on the internet without a password. He cannot blame not even the manufacturer, but there are lots of them. Back to the drawing board, we need something better. We need some way to detect these attacks in a better way. So we started to check behavior. What's the idea for behavior? Simultaneous calls in hours and off hours. So how many calls do you want to allow, international calls do you want to allow off hours, on the weekends or in the night? No more than 1. If someone is doing 3, 4, 5 calls during the weekend, is something really strange. Number of calls on hours and off hours. If I have 2 or 3 international calls on the weekend, it's okay. But 100 is completely out of behavior. Country of origin. Where are my phones? Using GeoIP location, I can know at least the country of the phone. Country of destination, to whom we are calling. This user is registered or not. The IP is on a blacklist, the dialed number is on a blacklist. So we have lots of questions that we can do to detect the behavior. The second thing is, another requirement is we need to make this simple for each user to implement. Right? And it needs to be available to any IPPBX system. So we started to work with some providers in a service delivered over SIP redirect or web service. The idea was simple. To have a server, like we call the FPS, the Fraud Protection System server, and the database. So what we are using is a SIP request. We do a SIP request for call approval to an FPS server. And we send the number and lots of information to the server. And when we do send us this information to the server, it returns a code saying, okay, this call is okay, or this call is not okay. This call is a risk, or this call is not a risk, depending on the behavior in an algorithm that takes in consideration several things, like user agents, IPs, blacklists on dialed numbers. Let me show you. I will not be able to show you everything because the time is really constrained, but I can show you this here. We have 3 machines here, the FPS and the test gateway. And in the demo, we have 2 situations, right? We have a phone here that it's connected directly to the PBX, and we have external users being connected through an SBC. And there are communication between the servers and the FPS server, using SIP redirect. So I'll take this BRIA server, and I'll make a call to an international call for a number that is on a blacklist. This number is blacklisted. We have honeypots analyzing traffic all the time and grabbing this information. Which numbers the hackers are dialing, from which countries, and everything. I would say easily block the 37.8 prefix is today the number one, and most of the frauds are going right now to Palestine. Usually 9725 something, right? In most cases. There are other cases, but these are the most serious. So I will make this call, and it will return something. You cannot have audio, so let me show you this here on the test gateway. I will not be able to show you the details, so if you want to know anything more about the system, I will be on the OpenSIP's booth if anyone wants to discuss this anymore. I will not have enough time, so set debug off. Let me show you what happens here. Okay. Let me go back. So the call is sent. And when the call is sent, we are adding some headers to the system, like the IP address and everything. So we have advanced information about the attack. One of the problems in the provider is I don't have any vision of my customer. And now the providers, what they are doing, they are protecting their customers to avoid fraud. So they are going to the PBX of the customer, they are not installing everything, it's just dial plan. It's just a SIP request, right? So they send the SIP request with the header, with the specific headers like received, user agent, dialed number, and send this in number of simultaneous calls. So we know from the PBX the number of simultaneous calls. It sends to the fraud prevention server that I can show you here. They dial. Look, it's a dial. Dial SIP/fraud check. It's just the IP address. It's like a normal SIP call. And what the server do is it sends a 302, move it temporarily, is a redirect with the fraud check, and now we have this code in front of the number, R03. R03 means for me, the dialed number is blacklisted. So in the dial plan now for R that is reproved, I will play the TT whistles. I can show you the dial plan. If the call was approved like a normal call, let's say for Miami, I would receive an A00. Something like this call was approved. Right, so I have an external engine to protect fraud that can be easily installed on any PBX, and you analyze at least 10 or 12 different aspects of a simple call. So now we are not protecting just the PBX, just the soft switch. We are protecting the PBX of our customers and the phones of our customers. So if I have an invasion on a phone that was left open, I will know that there is a behavior here that is wrong. So I can alert, and more, I block it in real time. So this call will not go through. Right, so it's possible to block in real time. You can go even further, using an SBC in front of your PBXs. I like the idea of an SBC in front of the PBXs because you can have a single point of protection. Mainly for SIP providers, it's very hard to protect 10 machines. I have a SIP provider say, okay, I have 10 SS7 gateways from different manufacturers, 2 SIP proxies, 3 or 4 media servers, lots of phones and everything. How do I protect everything? Okay, no. Update all your phones, update all your servers, change the operating system. It will take a year. And to be honest, how many of you have your phones updated? Raise your hand. How many of you have your operating systems updated? 10%, 5%? Maybe. So in many cases, not practical. You should do it, but most of people simply don't do it. So our first line of defense is still the firewall. And for SIP providers that don't have users inside, usually it seems to be a good idea. And in the SBC, you can protect against SIP flooding, RTP flooding using a pinhole firewall. Fuzzy attacks, you can hide the topology, and you can also load balance Asterisk and even remove SQL injection. So that's the idea of the SBC. Okay, last thing. This is the same thing, but now I will change the phone. This phone now, this same thing now will go through the SBC. And actually, the SBC is the same server. The only thing that changes is the outbound proxy. In the configuration of the phone, the only thing that changes is the outbound proxy. The configuration of the PBX does not change at all. It's completely transparent to the rest of the system. And the system is the same. It will approve or not approve a call based. So this call was established. And the SBC is a little bit different. For the fraudulent number, it will not even allow the call. It will reply a SIP request. It will make a SIP reply. It will not even send a message. Actually, what you're going to do with reproved calls is up to you. Right? So let's move ahead. There are lots of slides. Okay, now everything is okay. We have this fraud protection system and everything, and we have the fraud number 4. Even with all the systems, if the guy has access to the web interface or the SSH, you're done, because he can change the code. He can change the protection. This was one of the things that happened recently. It was a fraud of $3,000, $3,000 or $4,000. This guy was really merciful. They had the server open for a whole month and stole only $3,000. He could have made a fraud of $100,000 on the server. It was merciful. What is this? It's a vulnerability on a specific software, on a web interface. The guy simply went there and downloaded the etc password from the server and the M portal. So if you have a compromised server, the best thing you can do is do it again. Don't use a compromised service, because they have all the passwords. It doesn't matter if you go there and change the asterisk. They have the etc passwd. Right? And if they access the server, they can change the thing, unless you have an SBC. With an SBC and everything hidden behind the SBC, it becomes very hard to go there and check the web interface. Right? Or exploit the web interface. Okay, fix the vulnerabilities. Back to the drawing board again. And then when we had this thing with the web services, we went to the SBC structure. Single point of protection is something that I have already told you. I will do a demo here, but we won't have a lot of time. And to avoid the fraud number 5, that's the whole idea. One of the things we are doing also is disabling international calls at the T1 and E1 trunks. It's the safest possible. Because actually, I have seen frauds of $500,000. There are some cases in the US for $900. It can kill your company. It's not acceptable to put a PBX and risk the whole company. Right? So in many cases, you need to go to the extreme. Send international calls to a VoIP provider in prepaid mode. At least you have a limit on your losses. Automated log monitoring, total paranoia. We have an utility that monitors the log and sends an SMS to my cell phone. If any call with 00 in front of the number goes to my TDM trunks, I will receive an SMS. I don't want any. If someone changes the traffic and sends to the TDM, I will receive an SMS. And regular vulnerability assessment is also a good idea. Some of them. Conclusions. We now have the opportunity to be creative and protect our customers. SIP providers are going one step further and protecting their clients instead of just protecting themselves. Because by just protecting themselves, they cannot make, the protection is not effective. They don't have the visibility of the client. If the client is compromised, it seems to the provider that it's a legitimate client. Right? There's no such thing as a perfect security. Right? So Sometimes we are going to be frauded. I know that many of you have been. In the Asterisk world, lots of people have done. $4.6 billion on fraud were stolen from someone else's pocket, some of our pockets. And the risk of running an IP PBX in an unlimited TDM trunk is simply unacceptable. Don't do it, right? If you don't know anything about security and you're installing an Asterisk PBX connected to the internet and connected to a TDM trunk, you can kill your customer. You can kill your customer's business. If $100,000 and a phone bill of $100,000 would bankrupt thousands of small business. So in many cases, it's preferred to avoid installing a PBX than install an unsecure PBX on a TDM trunk. It's really, really risky. So that's it.